Welcome students, I am Ravi Shankar. So in this video we are going to study about the example problem 4.12 and 4.13 regarding the coefficient of mutual inductance, what we have studied in our last video. So let us go with the example problem. So example number 4.12 and it is available in the page number 217. So take your book and let us go through the problem. You just follow me. I am reading it out. See, the current flowing in the first coil changes from 2 ampere to 10 ampere in 0.4 seconds. Find the mutual inductance between the two coils if an EMF of 60 millivolt is induced in the second coil. Also, determine the magnitude of the EMF induced in the second coil if the current in the first coil is changed from 4 ampere to 16 ampere in 0.03 seconds. Consider only the magnitude of EMF. No need to put the negative sign, that's all. See, what is the problem given? The current flowing in the first coil changes from. So in the first coil, current changes. So let us take this as case 1. Current changes. So change in current, I am taking it as D. In the first coil, so I am taking it as I1. So the current changes in the first coil represented as DI1 from 2 ampere to 10 ampere. So change in current is final current 10 ampere minus the initial current 2 ampere. So the change in current is considered to be 8 amperes. Then this is taking place in a time of dt seconds, that is 0.4 seconds. So dt I am taking it as 0.4 seconds. Because of that, an EMF is induced in the second coil. Let us consider the EMF induced in the second coil as E2, which is 60 millivolts, 60 into 10 to the power of minus 3 volt. If so, you are asked to calculate what is the mutual inductance. Then again they are asking, that is case 2. Let us consider it as case 2. What is that case 2? Determine the magnitude of the EMF in the second coil. Again they are asking now E2. If the current in the first coil changes at a rate of, our current in the first coil is, or change in current in the first coil is DI1, which is equal to 4 ampere to 16 ampere. So the final current is 16 ampere and it is changed to what? The initial from 4 ampere. So change in current, we are considering it as 12 ampere in a time of, so dt, which is equal to 0.03 seconds. Consider only the magnitude of the EMF, that is E2 is asked. See, first of all, I am considering what is the mutual inductance available. The mutual inductance available, M is equal to, I can write the formula like this, M is equal to minus of E2 divided by DI1 divided by dt. If that is the case, the magnitude of the EMF is given. So let us consider the formula like this. E2 divided by DI1 divided by dt. On substituting, I can get mutual inductance M is equal to 60 into 10 to the power of minus 3 divided by DI1, change in current is 8, divided by, what is dt? dt is considered to be 0.4. On simplifying this, I can write like this, 60 into 10 to the power of minus 3 into, taking this 0.4 to the numerator, I can write 4 into 10 power minus 1, whole divided by what? Whole divided by 8. Simplify, you will be getting the answer as 3 into 10 to the power of minus 3 Henry. This is the value of the mutual inductance between the pair of coils. See, you can simplify directly. See, 10 power, Here 1 0, 10 power minus 1, this 4, this 8, we can able to get it cancelled. So we will get to 6 divided by 2 is 3 into 10 to the power of minus 3 Henry. Now, what is the EMF induced if the current changes from 4 ampere to 6 ampere in a time of 0.603 seconds? That is case 2. So let us solve this case 2. The EMF induced is given by the formula E2 as this magnitude of the EMF, which is equal to what? Which is equal to M into di1 divided by dt, which is equal to, what is the value of M? In the previous case, we have calculated it as 3 into 10 power minus 3. So you substitute 3 into 10 to the power of minus 3 into, what is the change in current? It is 12 ampere whole divided by time taken. What is dt? dt is 0.03. Okay, 0.03. When I am cancelling this, I can write like this: 3 into 10 to the power of minus 3 into 12 divided by 3 into 10 power minus 2. So you can able to get like this. When I am taking this, you can write this 3 and this 3 will get cancelled. And I am cancelling these two, I am getting it as 10 power minus 1. So the EMF induced E2 equal to 12 into 10 power minus 1 volt, or we can write E2 equal to 1.2 volt. So the EMF induced in the second coil is 1.2 volt. Hope you should have understood this problem. Okay, let us move on to the next one, problem number 4.13. See, come on, let us go with the problem number 4.13, available in the page number 218. Come on, follow me. Consider two coplanar coaxial circular coils A and B as shown in the figure. The radius of the coil A is 20 centimeter, while that of the coil B is 2 centimeter. The number of turns in the coil A and coil B are 200 and 1000 turns respectively. Calculate the mutual inductance between the coils. Then if the current in the coil A changes from 2 ampere to 6 ampere in 0.04 seconds, determine the induced EMF in the coil B and the rate of change of flux through the coil B at that instant. Come on, go through the problem again. Consider two coplanar. So the two coils are available in the same plane. Coaxial, axis for the two coils are same, and they are circular in nature. One of the coil is A and another coil is considered to be B. So let us draw the diagram here. One of the coil I am taking it as A, and another coil I am considering it as B. Both are in the same plane, having the same axis. What it is given? See, the coil A is having an radius of 2 centimeter, while the coil A is having an radius of 20 centimeter. Then number of turns in the coil A, NA, is taken to be, see, the radius of the coil A is 20 centimeter and coil B is 2 centimeter. The number of turns in coil A is considered to be 200, whereas the number of turns in coil B is taken as 1000. What else given? Calculate the mutual inductance between the coils. So from this, the first concept asked is, what is the mutual inductance? First of all, let us calculate this and then we will move on to the next one. What else given? What else given? If there is a change in current in the coil A, so I can write DIA. Changes from where to where? Changes from 2 ampere to 6 ampere. So 6 minus 2, change in current, I can call it out as 4 ampere. in a time. So what is the time given? dt is 0.04 seconds. Determine the induced EMF in the coil B. So you are asked to calculate the EMF in the coil B. Then also they are asking what is the rate of change of flux at that time in the coil B. Okay. So these are the given data from which first of all we have to calculate the mutual inductance, and after calculating the mutual inductance we have to go for the EMF induced. So how I can write? See, the current is changing in what? The current is changing in the first coil. So due to the change in current, a magnetic field will be developed at the center of the circular coil. You might have studied the formula. See, magnetic field. In the third lesson, you might have studied magnetic field at the center of the circular coil is given by magnetic field is given by the formula mu0 into n into I divided by 2a, where n is the number of turns available, I is considered to be the current passing through that coil, and a is the radius. So what we will able to get now? See, but now I am writing like this: due to change in current in coil A, the magnetic field produced at the center of the coil. So the magnetic field at the center of the coil is B is equal to, so you substitute mu0 into number of turns is, I can write number of turns available is, I have to write it out as Na. Then current in that coil Ia divided by what? Divided by 2 into R of radius of A, or I am considering it as the radius as small a for A. See, if that is the case, I am writing this magnetic field due to the current supplied in the coil A. So magnetic field at A or due to A at the center. So I can substitute this. What is the value? Mu0 I can substitute as 4 pi into 10 to the power of minus 7 into number of turns available considered to be 200. Let us consider the current in the first coil. I am taking it as Ia itself. Okay, Ia whole divided by 2 into radius of the coil A is what? Radius of the coil A is 20 centimeter. So I am writing it as 20 into 10 to the power of minus 2 meters. So when you are simplifying this equation, this 20, 200, everything, when you are simplifying this, you will be getting the answer as 6.28 into 10 to the power of minus 4 into current through the coil A. Take this as equation number 1. See, I have calculated the magnetic field that was being produced at the center due to what? Due to the coil A. Now, because of that magnetic field, a flux will be linked with what? A flux will be linked with the coil B with number of turns available as NB. So I am saying, therefore, I am calculating what? I am calculating magnetic flux linked with the second coil, or I can say linked with the coil B with number of turns as NB, with the number of turns NB. So what you can able to get, the flux available is phi of B, but due to the number of turns as NB, so I am writing it as NB. Okay, I am taking it as capital N, NB. Here also I can write this as capital N, no problem. So NB into phi B is equal to, I can write NB into, what is phi B? Phi B is magnetic field that was being available due to A multiplied with area of the coil B. because flux is considered to be magnetic induction multiplied with the area. See, magnetic field at the center is now linked with the coil B. So we are writing magnetic flux phi B is equal to BA, magnetic field at the center multiplied with the area. That is for a single turn. If you are having number of turns as NB, then multiply it with NB. Now I can write NB into phi B is equal to, what is NB? NB, we are considering it as 1000. Multiplied it with BA. I have calculated the value in the previous case as 6.28 into 10 power minus 4 into IA. Multiplied with, what is the area of the coil B? Area of the coil B is pi r square, because it is a circle. R square, instead of R, I am putting radius of B the whole square. Again, substitute, you will be getting 10 power 3 into 6.28 into 10 power minus 4 into, instead of pi, I am putting 3.14. Instead of RB, radius is 2 centimeter. So 2 square is 4 into 10 power minus 4 into what? Into current in the first coil. This we are saying it as NB into phi B. Total flux that is linked with what? Total flux that is linked with the second coil. So total flux linked with the second coil. On simplifying this, I can state, or on simplifying this, I can go, I am able to get the answer as 7.89 into 10 to the power of minus 4 IA, current that is passing through this. I am taking this as equation number 3, which is equal to NB phi B. Now we know the formula for mutual induction. What is the formula for mutual induction? I can write the mutual induction as, see, I can write like this. See, I can write the mutual induction as, see, M, mutual inductance in between the coil A and coil B is equal to total flux NB phi B divided by NB phi B divided by the current that is passing through, that is IA, which is equal to, what is NB phi B? It is equal to 7.89 into 10 to the power of minus 4 I into A divided by, what is the value of IA? The value of IA, again I am writing it as IA. So this IA and this IA will get cancelled. So the mutual inductance M is equal to 7.89 into 10 power minus 4 Henry is the mutual inductance available in between the two coils A and B. This is case 1, first concept asked. What is the second one asked? What is the EMF induced in the second coil? That was the question asked. So case 2, or ask this 2. See, ask this, the EMF in the second coil. What is the EMF in the second coil? We can say the EMF in the second coil as E2 is equal to minus of M into DIA divided by dt. So what is the EMF then? E2 equal to minus of, what is M? M is 7.89 into 10 to the power of minus 4 into, what is DIA? Change in current, I am taking it as 4 ampere divided by, what is the time taken? Time taken is 0.04 seconds. So when you are simplifying this, let us write like this, E2 equal to minus of 7.89 into 10 power minus 4 into 4 divided by, this 0.04 can be written as 4 into 10 power minus 2. So these two will get cancelled and these two will get cancelled. So the resultant is 7.89 into 10 to the power of minus 2, 10 to the power of minus 2. Isn't it? Am I correct? M, it is given as 7.89 into 10 to the power of minus 4. Then I will be getting here as 4 divided by, what is dt? dt is given to be 0.04 seconds. So on simplifying, I can get the answer as minus 7.89 into 10 power minus 4 into 4 divided by, instead of 0.04, I can get it out as what? Instead of 0.04, I can get it out as okay, 4 into 10 power minus 2. On simplifying, I can get E2 equal to minus of 7.89 into 10 power minus 2 volt, or this E2 can be written as minus of 78.9 into what? Into 10 to the power of minus 3 volt. Or we can write like this, how this E2 is equal to minus of 78.9. When you are removing that 10 power minus 3, you will be able to get it out as millivolt. See here, the negative sign indicates EMF is induced in a direction opposite to the direction in which flux changes, See, if magnitude of the EMF alone is being asked, see here they have asked only determine the induced EMF. If it is induced EMF, we have to consider it in terms of minus. If magnitude alone is asked, then magnitude of EMF means, then you can write it out as 78.9 millivolt. Okay, what is case 3? What is the third problem or the third question asked? You see, determine the induced EMF in the coil B and the rate of change of flux through the coil B at that time. See, what is the rate of change of flux? d phi B divided by dt is the rate of change of flux. Is nothing but the EMF induced E2. If you want to give it in terms of the direction, according to Lenz's law, if you are getting it as minus, then this rate of change of flux is nothing but the EMF induced. Therefore, EMF induced E2 is equal to the same value, that is minus of 78.9 millivolt. Since rate of, we can write like this, rate of change of flux is EMF induced. So the same answer you will able to get. Hope you should have understood this problem. You can solve this problem in a neat manner. So try to solve it out again and again. You can able to do it by yourself. So let us see in the next video for the next concept. Until then, goodbye and thank you from Ravi Shankar.